Oh, hello, ladies and gents. So we know this test is coming up. You've got your FRQs, so please be, working through those and making sure you got any, um, you know, questions answered related to that. What I'd like to do now is look through a list of concepts that I found on the multiple choice part of the test. I basically looked through the multiple choice part of the test, and anytime any sort of concept popped up, I just made a list of it there. Now, some of these are um, addressed multiple times through various questions. So, looking at the first bullet there, protein structure, know the difference between primary structure, secondary structure, tertiary, quaternary, stuff like that. One key difference is between tertiary and quaternary. Tertiary structure is created by one polypeptide folding up, becoming a specific three-dimensional shape, and becoming an active protein. Quaternary structure is multiple polypeptides being linked together to create new proteins. Know the parts of an amino acid. You got the amino group with the nitrogen, the carboxyl group with a couple oxygens, the alpha carbon that's got four different partners, including its hydrogen buddy, and then, of course, that R group. And R groups have unique chemical characteristics that make them all behave differently. There are a lot of questions that relate to structure and function. So, the idea is change the structure, you change the function, right? Polar versus nonpolar substances. Again, the biggies are oxygen and nitrogen. If there's oxygen and nitrogen, they're electronegative. They make polar molecules, and polar molecules behave differently than nonpolar molecules. Know the combinations of atoms found in each of the big categories. So, CHO with a lot of O, CHO with a little o, CHONS and CHOMP. That'll be very valuable. And I'd make sure I definitely hit the macromolecules. This test goes over macromolecules pretty heavily. Hydrolysis and dehydration synthesis. Remember, hydro means water and lyse means to split. So you basically add an H and an OH, and that breaks the bond and it keeps the molecule separated. So with hydrolysis, you're breaking bonds and adding an H and an OH, so it consumes water. With the dehydration synthesis, to dehydrate means to remove water, right? So with the dehydration synthesis, you're forming bonds. You take an H and an OH out of neighboring molecules, and then that forms a covalent bond between them. Okay, so hydrolysis adds water, breaks the bond. Dehydration synthesis removes water and creates a bond. So you might review that visually. Things up on the computer. I can find that. All right. So maybe this image is good. There, with the dehydration synthesis, you're pulling water out and forming a bond. With hydrolysis, you're adding water to the molecule, and that breaks the bond. So here you see that H and OH help keep the components of the original molecule separate from one another. And then with the dehydration synthesis, you pull out the H and OH and form a covalent bond. So that's, I think, good way to review that visually. Let's see. The role of disulfide bridges. Again, disulfide bridges form covalent bonds, right? So it helps stabilize the molecule. Hydrolysis versus dehydration synthesis. Okay, well, we talked about that. Compare and contrast DNA and RNA. Remember, DNA is double-stranded, has a deoxyribose sugar, and uses thymine as a nitrogenous base. RNA is single-stranded, has ribose sugar, and uses uracil as one of its nitrogenous bases. Independent versus dependent variables. Independent variable, I control that, right? That's what you can manipulate. And the dependent variable is the outcome you're measuring. When you graph that stuff, your independent variable goes on the x-axis and your dependent variable goes on the y-axis. So you'll be able to track its change. Saturated versus unsaturated lipids. Saturated means it's all single bonds. It has straight tails and it packs in and forms solids at room temperature. Unsaturated lipids have double bonds, and those double bonds bend the tails and keep the molecules pushed apart so that they stay liquid at room temperature. Excuse me. Let's see if I can find an image for that. Let's look up molecular. Okay. So here's a nice comparison. There's your saturated fatty acid tail, all single bonds, is straight. Unsaturated has a double bond, so it's bent. So one's going to be solid at room temperature, the other's going to be liquid. All right. Polar versus nonpolar covalent bonds. Again, if you share the electrons differently or unevenly, it's going to create an attraction between neighboring molecules. Ionic bonds, electrons aren't shared, right? They're transferred. And so atoms that give up electrons become positively charged. Those that gain electrons become negatively charged. And they are held together by the attraction between oppositely charged particles. Of course, that can be busted by water pretty readily. Hydrogen bonds, again, they are the interaction between molecules. It's not about sharing or transferring electrons within a molecule. It's about interaction between the partially negative region of one molecule and the partially positive region of another molecule. And remember, in water, hydrogen bonds are breaking and forming all the time. How primary structure impacts tertiary structure. So primary structure is the order of the amino acids, right? And all those amino acids have their own R groups. So if you have a different order of amino acids, you're going to have the R groups interact differently. The protein will fold up differently, or the polypeptide will fold up differently. How R groups impact polypeptide folding. Again, we sort of talked over that. Be able to identify the 4 categories of large molecules by sight. We've got plenty of practice on that in some other videos. The general functions of the 4 categories. Carbs, think energy, like there's energy, and then cellular structure like cellulose. Lipids, it's membranes, energy, and messengers. Membranes and phospholipids, energy stored as triglycerides, and messengers like nonpolar hormones, like cholesterols and steroids, things of that nature. Nucleic acids, DNA, RNA, instructions for making and the machinery for building proteins. Review the properties of water. Be familiar with all that stuff: cohesion, adhesion, things of that nature. Then if you go over that kind of stuff, that sort of is a good way to look at the Flipgrid things that people have come up with. So just go through the various properties of water, know that hydrogen bonds are what's causing that kind of stuff, and then think about how that impacts life. Again, chapter 3 in your book organizes that stuff really well. Monomers and polymers. Monomers are small molecules, and then when they're linked together by covalent bonds, they can form these polymers. Peptide bonds are a specific type of covalent bond between amino acids. An amino group of one amino acid covalently bonds with the carboxyl group of another amino acid. What holds together the strands of DNA? Magic. Right? Now it's hydrogen bonds between those nitrogenous bases. So again, since the hydrogen bonds are relatively easily disrupted, that means that you can separate the strands relatively easily and copy the information down or use the information to make RNA, that kind of stuff. Specific heat of vaporization, surface tension. Again, review those properties of water and think about how they impact life, ways in which they impact life. All right, hey, work hard. You're doing a good job. Stick with it, and I'm sure you'll do well on that test.